2,500 years ago, priests in Babylon named the exact day the moon would block the sun. No telescopes, no satellites, no physics textbooks, only careful watching and patient math. Today, you press a button and see an eclipse forecast for 2050. Back then, someone pressed marks into wet clay and reached the same answer. How did ancient cultures figure out eclipses centuries before modern astronomy existed? Three separate civilizations solved this puzzle without ever talking to each other. Stick around because this story surprised me too. Picture Babylon around 500 BCE. Priests climb towering ziggurat platforms every night, built specifically for watching the heavens. Babylon treated astronomy as a government function, fully funded by the royal court. They track the moon across a dark sky. Scribes press wedge shapes into soft clay tablets. Scribes record every eclipse, every full moon, every strange light. The Babylonians called this practice celestial divination, reading the sky the way a modern analyst reads a stock chart. Priests name their growing sky, record the Enuma Anu Enlil, a collection stretching across 70 tablets in centuries of steady observation. Astronomers like Kidnu later built on this collection, sharpening the numbers even further. Generations pass, and the stack of tablets grows into a library of sky patterns. Kings paid close attention to this library. An eclipse, in Babylonian belief, threatened the life of the king directly. A missed eclipse warning risked more than embarrassment, sometimes costing a life. Here's the surprising part. These priests predicted eclipses with real accuracy, often naming the correct month, sometimes even the correct day. Records show Babylonian predictions landing within a single day of the real event, an accuracy rate modern historians still find impressive, especially out of hundreds of recorded lunar eclipses where scribes miss remarkably few. They did this without knowing the sun sits at the center of the solar system, and without knowing the moon travels around Earth on a tilted path. They found a pattern, then trusted the numbers. No formula explained why an eclipse happened, only a written record proved when one happened next. Reason 1 comes down to patience. Babylonian astronomers kept written records for over 3 centuries, logging every eclipse with a date. Scribes compared every new date against older entries, and slowly, a pattern emerged. Every 18 years, 11 days, and 8 hours, the same type of eclipse repeated. Historians now call this pattern the Saros cycle. Here's why 18 years matters. The moon takes about 29 and a half days to circle Earth once. The moon's tilted path crosses the sun's path at only 2 points called nodes. An eclipse only happens near one of these 2 nodes. This node crossing point explains why eclipses never happen every single month, despite a full moon appearing every month without fail. Every 18 years, 11 days, and 8 hours, the sun, the moon, and these 2 nodes return to nearly the same alignment. Babylonian scribes never needed the words orbit or node. Scribes only needed one number, written down and repeated for 3 centuries. Babylon didn't invent the rhythm of the moon, only noticed the rhythm before anyone else recorded the pattern. Picture a spreadsheet built by hand, one entry at a time, across 10 generations. No single astronomer lived long enough to see the full pattern alone. Fathers passed clay tablets to sons, and sons passed updated tablets to grandsons. The Saros cycle only reveals itself across a long human chain. Reason 2 comes down to math, not physics. You don't need to understand gravity to count days on a calendar. Babylonian scribes built number systems specifically for tracking cycles. Babylon used base 60 math, the same system splitting your clock into 60 minutes today. This system lets priests divide time into neat, repeatable chunks, and once you have reliable numbers, prediction turns into counting instead of guessing. Numbers, not theories, carried the entire method forward. This base 60 system did not stay buried in Babylon, since modern astronomers still divide a circle into 360 degrees, then split each degree into 60 minutes and 60 seconds. Every time a scientist points a telescope using degrees and minutes, a piece of ancient Babylon rides along. Babylonian scribes even split fractions using this 60-based system, long before decimal fractions existed anywhere else. Now travel west, toward ancient Greece. In 585 BCE, 2 armies, the Lydians and the Medes, faced off after years of bloody fighting over the same stretch of land. A philosopher named Talus had reportedly predicted an eclipse for the same year. Mid-battle, the sky went dark in the middle of the day. Neither side expected the sky to intervene in a war. Soldiers dropped their weapons in shock, while commanders on both sides read the darkened sky as a clear signal to stop fighting. The fighting stopped within hours, and a peace treaty followed soon after, sealed partly by fear and partly by exhaustion. Historians still debate how precisely Thales calculated the date, some crediting borrowed Babylonian records rather than original Greek math. Either way, one predicted eclipse ended a war. This single eclipse became one of the earliest dated events in recorded history, anchoring an entire timeline of ancient events around one dark afternoon. Here's a detail most people miss. Eclipse prediction wasn't a Babylonian trick alone. Ancient Chinese court astronomers held one of the most dangerous jobs in the empire. Eclipse records in China stretch back even further than one famous legend. Oracle bones from the Shang dynasty, carved over 3,000 years ago, already mention dark suns and vanishing daylight. Chinese astronomers treated the sky as a direct line to heaven, so accuracy carried religious weight alongside political weight. Legend says two royal astronomers, Shu and Ho, once failed to warn the emperor about an approaching eclipse. Emperors treated a missed eclipse warning as an insult to heaven, and legend says the punishment cost both astronomers their lives. Whether true or exaggerated, the story reveals real pressure. Chinese astronomers responded the smart way, building detailed calendars and cycle charts to avoid missing another warning. Centuries later, astronomer John Hung refined these calendars even further until missing an eclipse warning stopped being an option. Chinese court records also tracked solar and lunar eclipses separately, refining two independent calendars at once. Meanwhile, across the ocean, the Maya built an eclipse system with no contact with Babylon or China. Maya astronomers created the Dresden Codex, a bark paper book packed with eclipse tables stretching across decades. Maya priests tracked the same lunar rhythm using their own counting system, completely separate from anyone else on Earth. The Codex uses a base 20 counting system, built around dots and bars instead of digits. Priests marked warning windows, stretches of days when an eclipse became possible. Maya priests linked eclipses to an old story, one where a jealous god swallowed the moon whole. Myth explained the meaning behind an eclipse, math explained the timing. The Dresden Codex lists over 400 lunar months across its eclipse tables, an enormous span for a civilization working without metal tools or wheeled transport. 3 unrelated cultures. 3 separate methods. Maya astronomers additionally tracked Venus alongside the moon, treating the two cycles as connected omens for war and harvest timing. One shared result, the moon repeats on a schedule. So, what causes an eclipse, in plain terms? The moon orbits Earth on a path tilted slightly against Earth's orbit around the sun. Most months, the moon passes above or below the sun's position in the sky, missing a lineup completely. Occasionally, the tilt lines up, and sun, moon, and Earth fall into a straight line, with shadow landing exactly where eyes happen to be watching. Sometimes the moon covers the sun completely, creating a total eclipse and turning day briefly into night. During a total eclipse, the sun's outer edge, called the corona, briefly becomes visible to the naked eye, a sight ancient viewers found unforgettable. Other times, the moon covers only part of the sun, creating a partial eclipse most people barely notice. The difference comes down to exact distance and exact alignment on the day in question. Ancient astronomers never needed this explanation to predict the event, since knowing when worked equally well as knowing why. Modern telescopes only confirmed what old tablets already suggested. Compare this ancient method to modern astronomy. Today, scientists calculate eclipses using orbital mechanics, gravity equations, and computer models accurate to the second. Ancient astronomers skipped all of this. No gravity equations, no computer models, no explanation for why the moon moved the way the moon moved. Ancient astronomers needed only one thing, a long written record, and given 3 centuries of data, a pattern becomes visible, with or without physics. Modern software runs the same basic idea, only faster and with sharper tools, and space agencies still label eclipses using Saros cycle numbers today, thousands of years after Babylonian scribes wrote the pattern down first. Eclipse chasers today travel across entire continents chasing a shadow lasting only a few minutes, relying on math tracing straight back to Babylon. Here's a myth worth correcting. Many people assume ancient cultures only feared eclipses as omens, screaming at the sky and banging drums. Some cultures did react this way in the moment. In several regions, communities once banged drums and pots during an eclipse, hoping to scare away whatever creature seemed to be swallowing the sun. Some of these traditions continue today as cultural celebration rather than genuine fear. Meanwhile, the astronomers of the same era already held next year's prediction written down on a shelf. Fear filled the streets, math filled the temples. Both reactions happened during the exact same eclipse, in the exact same civilization. The same eclipse sometimes inspired both terror and precise science, depending entirely on which building someone stood inside. So here's the core idea. Ancient cultures predicted eclipses not through advanced science, but through patient record keeping and clever math. Babylon watched the sky for 3 centuries straight, while Greece watched one eclipse end a war within hours. China feared the cost of missing a warning and built sharper charts as a result. The Maya built independent tables using their own calendar system. None of these cultures understood gravity, yet all of them understood patterns. A pattern tracked long enough beats guesswork every single time. 3 civilizations, thousands of miles apart, reached the identical conclusion using nothing but patience and numbers. Would you have spotted the pattern? Would you have trusted 3 centuries of clay tablets over one frightening night sky? Drop your answer in the comments below. And if ancient science surprised you today, subscribe for the next story about how old cultures solved big problems long before modern tools existed.